Hey friends, thanks for joining us once again for another episode of STEM10 Plus. Today we're going to take a deep look at the things around us when we walk down the street, when we go to the grocery store, and really examine something that we interact with daily but really don't probably give too much attention to: color and sight. Today we have a very special guest, Dr. Grace Lee, who does just that. She is a scientist on sight and vision. She's going to be sharing with us today about rods and cones and how it is that we're able to see things in low light and in higher light. We hope you're as excited about this episode as we are. Can't wait to see it.
Hi everybody, good afternoon everybody. My name is Grace Lee. I'm a vision scientist. What does vision scientists do? We basically study eye. As you know, eye is not that simple because when you look at it very closely, it has a lens, blood vessels, and some muscles. And on the back of the eye, there's something called retina, and so on. So it is very complicated and complex. So today we are not learning complicated structure of the eye, but we are going to learn about one part of the eye that is very important for color vision. So today's question is, how do we see color? Anyone know? Anyone? No? No? So we're going to find that out, okay? So we are going to make some cells that are important for color vision. So what are cells? Every living things have cells. Some have one cell, others have many cells, like us, you and me. Group of cells make things in our body, for example, heart, eye, and so on. The cell talk to each other to work together, make things function to create happy environment in our body. Today, I want to invite you to make color cones with me. So we do need this balloon, colorful balloon that has red, blue, green. And we need a fudge stick, okay? And we also need some color paper, okay? So I blow some air into this yellow balloon, and we pretend that this is the sun. And sun emits or generates lots of waves like this. It looks like a noodle. I don't know about you guys, my favorite dish is noodle. I love noodle. So the wave has a wavelength, and the one complete wave cycle is called wavelength. So the uppermost part of the wave to the next uppermost part of the wave. And there are different lengths of wavelengths emitted by the light. And the wavelength corresponds to particular color of the light. Okay? For example, long wavelength of the visual light, we see reddish color. And then medium wavelength of the visual light, we see greenish color. And the wavelength, as the wavelength gets shorter, like this, we see bluish color. Okay. So how do we see these colors? In the back of the eye, there is something called retina. In the retina, there are cones and rods and many other cells. The cones, they are very important for daytime vision, and rods are important for night vision, and they are the light sensitive cells in the retina. Okay? But today we are going to focus on cones in the retina. Okay? So let's start by making cone cells. you need a balloon, red, blue, green, and then blow each balloon. Tie this. This is going to be the cell body of the cones, okay? And for green, find a green paper, okay? And then fold this to make a triangular shape. Like this. Okay? And then this is where all the chemistry of the cones are happening. So use the Scotch tape to just make the triangular like this. Okay, and then I'll put this on top of the balloon. And then again, I'm using the tape to make it run faster. So like this. So, and then the fuzzy stick, you tied it on that area. Like this. And then it has something like this shape, right? And then at the end, just make it a little bit bulky. So voila, this is how the cone cell looks like. Okay, so this is where all the chemistries are happening, and this is the cell body of the cone, and this is something called axon. Whatever that is happening, they have to transfer to the cell body and to here, to axon, and something called axon terminal, so that they can transfer the information to the other cells in the retina. Okay, so I made this green and blue and red. Okay, so the reason I made different color of cones is that in the retina there are 3 different types of cone. One is long wavelength cone, which is most sensitive, and there is medium wavelength cone, which is most sensitive to greenish light. Okay, the M cone. Okay, and this is L cone, and there is a short wavelength cone, which is most sensitive to bluish light. Okay, so remember, it doesn't mean that the color of cones are red, green, or blue. They are just sensitive to those wavelengths and amount of the light. Okay, so when there's sun or light, it emits, it generates lots of waves, like I said before, and most of the waves are observed by any objects, but some reflect and goes into your eye. Okay, and it hits those cones in the retina. Okay, so for example, when there is blue light, short wavelength wave, then the red cone doesn't react. Okay, it's not happy. However, on a green light, it acts a little bit, but on a reddish light, it reacts a lot. It's very happy and it's excited. Then what happens is that excited cone sends all that information to the brain, and brain takes its information based on it and make you think that it is red. Okay? And this is how we see different colors in the world. Okay? So what do you think when some of the cones are not working? We have L cone, M cone, and blue cones. So person with L cone, the long wavelength sensitive cone, if there's a problems with this cone, then they tend to see green, yellow, orange, red, and brown as being more similar shade of color than normal, especially in a low light. And person with middle wavelength sensitive cone problem may experience the confusion between the colors such as green and yellow or blue and purple. Okay? And person with the short wavelength cone problem may have difficulty distinguishing some blues from green and some yellows from violet color. And there are some who cannot see any color at all. So to them, the world is black and white movie, but the case is very rare. So, is there a treatment for color blindness? Not yet, but researchers or scientists found that doing a gene therapy, which is changing damaged cell to a good cell to cure or fix red and green color blindness in adult monkey. So this accomplishment is an important step towards developing gene therapy treatments for eye conditions in humans. Take-home message is that there are 3 different types of cones in the retina: short wavelengths, long wavelengths, and medium wavelength cones. Okay? And they are excited based on the wavelength of the visual light. And when cones are excited, they send the information to the brain, and brain takes this information and let us know the color of the objects. So thank you for listening, and please let me know if you have any question. Okay, bye.